Listeners, welcome to the video on simulation of solid state drives. In this video, we are going to see how to simulate the speed torque characteristics of an induction motor using Simulink. Let us go to the new Simulink model, create a blank model. In this blank model, I go to library browser. In the library browser, I go to Simscape. In Simscape, go to electrical, specialized power systems. In the specialized power systems, you have electrical machines. Go to electrical machines and you have an asynchronous machine SI units. I take it and put it on the untitled Simulink file. Double click on this. Select the rotor type as squirrel gauge and preset model. I'm going to take a model which is a 5.4 HP, that is 4 kilowatt, 400 volts, 50 hertz, 1430 RPM model. It is a preset model. Mechanical input I give as a speed, and reference frame I give it as a stationary reference frame. Click apply and give OK. Now in the same specialized power systems, you have sources. Under sources, you have three-phase source. Drag it and put it on the screen. Connect this A to A, B to B, and C to C. Double click on this source, and you could able to see here that in the asynchronous machine, we have taken a 400 volt machine. So I give face to face RMS voltage as 400 and frequency as 50, and I don't want any internal resistance, inductance, base voltage, everything. So I remove this internal, click apply and give OK. Now this is a three-phase source which is capable of generating a 400 volt face to face, that is line to line voltage. Line voltage. Now I take a Simulink commonly used bus selector. Under bus selector, I double click on this bus selector. Sorry, you can connect this measurement to bus selector. Double click on this bus selector. Here I'm going to view the rotor speed and electromagnetic torque. So I add both of them, rotor speed and electromagnetic torque. Remove these two signals from it. And this is supposed to be my measurement point for the system. So let me drag it and put it comfortably on my screen. And let me take the RPM, which I supposed to give it as an input here. So for which I take a gain block because it is asking in radians per second, it is a omega. So I want to multiply this RPM into 2 into pi 2 pi n by 60. So I put 2 pi n is this RPM by 60. Apply, give apply and give OK. And this RPM, let it be 200 RPM. 200 RPM is converted into radians and it is given as an input here. Let me take scope, which is available in sinks. Go to scope, take it, put it on the screen, double click, go to its settings, give two input port and close this. And now go to scope, display grid. I need two windows for it. So I put like this and I'm displaying the speed as well as the electromagnetic torque. And this torque is in radians per second. So I convert that into RPM, for which I want to multiply it with 60 30 by 60, 60 by 2 pi. So this becomes 30 by pi. 30 by pi. Click apply and give OK. And to display the speed, let me use a display which is available in the things. Connect it like this. And to have a simulation to run by using Power System toolbox, I need a Power GUI. Let me take that also and put it on the screen. And I want to add the data points which is available in sinks to workspace block. One to load the data of the speed, other one is to load the data of the torque, because I am interested in plotting the speed torque characteristics. So I need this torque and speed, and I also need the torque to be displayed here. So let I display the torque also. So this variable I change it to capital N, and this variable I change it to capital T. Capital T. Apply and give OK. Now everything is completed here, and I'm supposed to run the simulation now. Now I close this window, run the simulation. For 200 RPM, I'm running the simulation, and RPM is 200, machine is also rotating at 200, and the torque is supposed to be 69.86. So this I record it in my M file, which is available here. Let me go to that M file. Is here for 200 torque. I mention the value of the torque which is available here, which is 69.86. So I type this 69.86. Then similarly, I'm going to run that simulation for 300 RPM. Again, change this to 300 RPM. Click apply, give OK, run the simulation and note down the readings. Now the torque is 73. So again, go to the Simulink file. I put 73. Again, I run the simulation for 400 RPM. I make the changes in the speed, 400 RPM, run the simulation. Now the torque is 76.31. Again, I used the M file to upload it. Now I change the simulation to 500 RPM. Apply, give OK, and then run the simulation. Now it is 79.71. So I again make 79.71. Again for 600 RPM, I make a changes in the speed again, 600 RPM, again run the simulation, and it is 83.1, again 83.1. Likewise, I do the simulation till 1500 RPM. I do the simulation till 1500 RPM. Let me note down all this data. For 1500 RPM, I change this to 1500 RPM. Click apply, give OK, and run the simulation. Now it is 1.268. I record this here in the 1.268. Now I am plotting this speed versus torque characteristics. Let me run this file. So go to editor, run it, and you could able to see there is some error on the line 3. Dimensions are mismatching. Let me check how many data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 1430 is missing. So again, I go to Simulink. Let me put 1430. 1430. I did not simulate. 1430 I simulate, and it is supposed to be 29.76. Let me record it before here. 29.76 and 76. Now let me run the simulation. Yeah, you could able to see the graph. It is slowly popping up. Yeah, this is the speed torque characteristics of the induction motor, and this is supposed taken for a condition of supply voltage of 400 volts. Now I reduce the voltage to 380. 380, apply, give OK. Again, starting from 200 till 1500, again you are supposed to take the reading. That reading is supposed to be the next reading. You keep that as N1 T1. Hold on this plot. Again plot N1 T1 in the same graph. You will get a family of curves of this speed torque characteristics. And you are supposed to make this plot in the record notebook. Let me show that for the voltage of 380 volts. I changed this voltage to 380. Now again I start from 200, click apply, give OK, run the simulation. Now you get 63.05 as torque. I record this. You record this in the table which is given in the documentation for 380 volt. Again, all this speed for a 200 RPM, what is the torque? For 300 RPM, what is the torque? For 400 RPM, what is the torque? Likewise, you have to record it for all the 5 sets of voltages just by changing the voltage in the supply, power supply. Now it is 380. I again keep 360, again take all the set of readings. 340, again take all the set of readings. Likewise, you have to take it for all the 5 different voltages. Now I have taken readings for 400 volt and 380 volts. Now I'm holding on the same plot which is already plotted. So let me use hold on, since I want to plot it on the same graph. Plot N1 comma T1 on the same graph. So this one was for 400 volt and this one was for 380 volt. Let me run this. And you could able to see the graph. Now this is for 400 and this is for 380. Similarly, you are supposed to take readings for all these 5 different voltages and plot a family of curves. That is, you should be having 5 curves here and record it in your observation. Thank you for your patient listening. Thank you.